Hey everyone, let's take a look at a problem from section 3.7, operations on functions. We're going to concern ourselves with what I think is the most complicated, but a very important operation, which is function composition. And this will be very useful when you get to calculus. You'll be doing things with the composition of functions, so it's good to understand exactly what it is. Looking at these problems, I don't know, let's do something a little... Let's do 32, okay? I guess the directions are a little bit cut off, but what they say is you want to find f of g of x and g of f of x. Okay. The book also wants you to state their domains, but we can mention that. We can mention that, but it's not, that's less important to me. Okay. F of g of x. Remember, that means that we are plugging g of x into f of x. So I encourage you to write it this way. F of g of x means f of 3 over x. And that way you know that you're saying 3 over x over x minus, over 3 over x minus 2. You see, everywhere we saw an x in f, we just plugged 3 over x in. Okay. And if you wanted to make this a bit nicer looking, you wanted to simplify this, stay over here just for space constraints, multiply the top and the bottom by x, and you're going to get 3 over 3 minus 2x. Now let's take a look at g of f of x. Remember, this is going to be g of f of x, right? So this is g of x over x minus 2. And remember further that we're plugging that in for x, so we're getting 3 over the quantity x divided by x minus 2. Now, remember the way that fractions work, right? This is the same thing as 3 times the reciprocal, x minus 2 over x, which is 3x minus 6 all over x. Okay, so that's how you would do that. And just really quickly, to look at things, right? If we look at the domain, right? If they ask for the domain of these functions, well, just note that if we're talking about f of g of x, well, g of x, right? G of x is 3 over x, right? So we're not allowed to plug in x equals 0. Right? Because g of 0 does not exist. But looking at our final expression, we also see that x cannot equal 2/3. Because I guess you would say, well, just f of, well, I guess it's not really f of 2/3, is it, right? But it's more that f of g of 2/3 does not exist. Right? So the domain, I guess, is everything else. Right? Now, here, we sort of have the opposite situation, right? Here, x cannot equal 2 because f of 2 does not exist. And I think further we see that x cannot equal 0 because f of g of 0 also does not exist, right? We have this situation here, right? Divided by x. Okay. So try doing another example. Maybe try doing, I don't know, 31 or 33? See what you got.